Okay. So where are you doing working in class right now? So in which lesson you are in?
We've just got to 9.7.
So are you taking these topics or not yet?
Standard equation, tangent. We didn't really know the ellipsoid. We haven't done. We
Uh-huh.
barely started looking at it. Exactly, I can tell you where we are.
Okay.
Today we did, yeah, we're working vector.
Mm-hmm.
Um, we stopped at 9.8 book
9.8. Okay.
line integral.
Okay. So we've taken an idea about those questions like
Last
yeah,
class.
equation of lines in space, planes, okay, different situations between line and the plane, working in surfaces and relations related to planes or lines in space.
Mhm.
So given a surface with this equation, you want to find the tangent plane to the graph at a point. So what do we do? Now the tangent plane has to do with the delta f, which is the normal of the plane. Standard equation of the tangent plane has to do with the normal. So the plane has a normal factor and a point in the plane, which is the point P right here, P. So P is given. All you have to do is to get the normal. Now, what has the normal to do with the surface? Because the normal would be delta F. That's it, okay?
Yep.
So you know that delta F, the partial derivatives fx of y is the vector. We don't have a z here, yeah, fz. So in this case, by the way, you have to put this c minus or this minus z.
Thank you.
Okay, you can rewrite that as 5x squared instead of changing all those coordinates or all those, let's say, terms. I would prefer just kick this to the other side. You know the trick, because right here you have a z, and the
Yeah,
z is not
it's not included. It's basically just f of
so
x.
you wanna equate it to this is equal to z, which is minus z now. So let us find the partial. So this is a vector. Okay. Yeah, let's find. So how much is fx? Okay, so you are deriving this with respect to x. You get 10x plus y.
Mhm.
Okay, you can plug in the point
Um,
away. So it is 30 minus 2. Okay, fy. Deriving with respect to y is an x minus 4y. So you have the x plus 8. Okay, fz, which is minus 1 right away. Okay, with respect to z. So this is minus 1. Hmm? Okay, now equation of the tangent is, it's equation of a plane, by the way. So equation, it's, you can call those, if you want, ABC, or you can say it's fx into x minus x of the point. This is the relation, fy, y minus y plus fz, z minus z of the point. Is it okay? Okay, just replace those numbers. You get the point of has an x. Okay, next we have the y, and the z is a minus into z minus 30. Now on what work, yeah, it's not written how you want to present your answer. Sometimes they say z equal. If they say z equal, you would isolate. So I guess here it's equal. You can check it up, okay? I guess you can plug in what you see as it is, and including factors, including the zero. Check it up if you want. Okay, but this is, by the way, you can
straightforward.
but they prefer you to simplify it. Okay, the test they prefer to simplify. Simplify in a sense, I mean, just collect all the constants. So it's 28x with the 11y minus z, and just collect all constants equal to or the constant equal. I mean, just calculate the constant. Okay, you can do it. Okay, this is the way how you present it in a test usually, because to look to have it of a tangent plane.
I input exactly how we did it, and it automatically did all the math, and then it gave me wrong.
Which one? Now this one?
Yeah.
Okay.
It ended up giving me the exact equation we have. Exactly as we put it there.
So you put it equal constant or equal 0?
Equals 0.
Equal
And then
0 and
the system itself did it
compute the
did
constant.
it there.
So what was wrong in it? The way you
I
present.
just put the y minus 2 instead of y plus 2 for some reason.
Okay, perfect. Okay, good. So number 1 is done. Perfect. Any question? Good.
Pretty straightforward.
Yeah. Number 2. What do you apply in number 2?
Would it be the same thing?
Yeah, find all the points where the tangent plane is parallel to another plane. Now, the situation is you have a plane parallel to another plane. So what you get, always for a plane, you deal with the normal for it. So you have normal one, and you have the another normal for the second plane, right? So when the planes are parallel, it's written P1, plane 1 parallel to plane 2, then the normals should be parallel. Do you agree? Okay, I mean, like students to express the way or the process of solution. Okay, I mean, this is a perfect answer. If you present this, would be good, because other students would right away do answer using numbers without writing what they are doing. Okay, so planes parallel means normals are parallel. Now the normal to the plane, as usual, again, it is the gradient. So it's delta f1 parallel to delta f2. Is it okay? Because the ellipsoid surface, okay, is a shape that vector which is normal to the surface. So again, by the way, that you can collect minus 17, but it won't matter here because it's a constant. But we prefer to do the steps. So this is the surface, you can call it F. So F in X, Y, Z, okay, is written to X squared plus 5Y squared, Z squared. Let me push this a little. Perfect. Okay. So minus 17. So this is your surface representation. Okay, this is the ellipsoid. You can call it E. Okay, go ahead. So what?
You'd find the gradient first, so it would be 4x.
Okay,
plus,
so delta F would be 4x, comma,
then 10y,
10y, comma,
comma 2z.
2z, and that's it. So this is a vector, finish. Now this is, let's say, delta F1. You have another plane. So the plane delta F2 is your normal 2, I mean, normal vector. So this is the plane with a vector 4, 5, minus 2. You take those ABCs, okay?
Yeah.
Okay, now what property when you have parallel vectors? So the property, this means what? The property would be.
I wonder if it's dot product or the cross product. One of them has to equal 0. No, that's they're perpendicular if it equals 0.
Yeah, that's perpendicular. The property of parallel, what would be ratio proportion? Okay, ratio proportion are identical. Proportion.
I thought they were, but they're not.
So it means if you divide the first, second, third should be equal. That's it.
Yeah.
In parallel.
But
so for
no, it will give you 1 to 1.
Yeah. So, right? Equal to 4 minus 2. Now we didn't get a value, but you got the relations. Now there are many ways here to continue on. Here, I mean, sometimes you'll get this without a z. So you will have x, y in numbers. And to get the z, because you want to get all points to this, find all points. You want to find all points on the ellipsoid. You get it? So this belongs to the ellipsoid E. I mean, if you have two scenarios that may happen in a test, if you get X, Y to be numbers, so you still have Z, you get placing this in your ellipsoid. You get it? This is one scenario. Another scenario here, we don't have numbers X, Y, Z, but we have a relation. Is it? So what do you want to do? Replace those in your ellipsoid. So how do you replace? Some would say I want to get X in terms of Y, Z in terms of Y. Okay. Some would say I want to X equals something in Z, Y in terms in Z, and replace them. It's up to you. And another approach would be, if you want, parametric.
Oh, yeah.
It's up to you. You can get X, Y, Z parametric, replace all those in the ellipsoid, get T, and then get back with X, Y, Z. Usually we use this method if it is complicated forms. Now these are simple, I guess. Okay, you can name it parametric or no need. Okay, I guess get X in terms of Z. So X equals minus Z. Do you agree? Get Y in terms of Z. So 10Y over 5, you get equals minus Z. So Y equals minus Z over 2. Is it okay? Okay, replace those in your ellipsoid. You get the Z. When you get the Z, replace back, you get the XY. So this would represent the point or points. It depends how many values you get. Any question?
Oh, I
So,
wouldn't have, I would have not thought to do it this way.
so replace in ellipsoid. The ellipsoid is this. So Z squared equals 17. Okay, so you get this equation all in Z. X is this, Y is that. So we have 5y squared means, continue the calculation. How much would be Z squared?
Minus 2.
So this is
Third.
this is 5 over 4. This is Z squared. Okay. No, you have calculator. I mean, you can add 2, 5 over 4, and the 1.
So
So it's a 3,
13.
12, 17 over 4. Z squared equals 17. Then Z squared equals a 4. Do whatever you like. It's calculator issue. 17 divided by, you get 4. So you have values of Z, right? Plus minus 2. So you get 2 points, by the way, because of the Z. Anyhow, so X is how much? So let's write X equal minus Z, Y equal minus Z over 2. Okay, so you have the Z now. Now you say for Z equals a 2, you get the minus 2, Y to be minus 1. Z equal minus 2, you get another value, another point, which is minus Z. Y is minus half. Okay, so you get 1 over 1. It's the same thing, but only in minus, right?
Yep.
So you have 2 points, by the way. Has an X. So this would be minus 2, minus 1 with a Z2. Okay. And the second, we get X is a 2, Y is this, and Z is that. Finish. Any question? Both of you want to put with a comma, I guess. Okay, yeah, similar points, you put comma. Okay, so this question, as we said, this is the harder scenario, by the way, because you get X, Y, Z in numbers from the beginning. All those calculation happened because if that, for example, the Z disappear, you got X, Y in numbers. Now X, Y in numbers, Z is missing. You replace X, Y right here to get the Z back. Okay, but this is the way how you work it when you don't get X, Y from the beginning in numbers. Is it okay, clear?
Yeah.
Yeah. Next. Okay, number 3. Okay, what can we apply in number 3 here?
Tangent is
So this is an ellipsoid. The implicit tangent to this and the parametric form of the line. Okay, we have two questions here. So what is the implicit form of the tangent? Implicit form, it means a relation in x, y, z something, okay? Tangent plane. So we'll see how you're. Again, it's a plane and it's a tangent, so it works on delta f. Okay, again, you can kick this to the other side. So the ellipsoid would be x squared plus 3y squared plus minus 15. It won't affect, but this is how it looks like, equals 0. Or this is, you can say, it's the function, is the e in as a function of x, y, z ellipsoid. So you want to find the delta e. I call it not f, delta e. So you want to find its gradient. Yeah, go ahead. And you have like the ex, the ey, and the ez. Yeah, how much is ex?
2x, comma, or
Derive this with respect to x, you get
the x squared.
no. We have here x
2x,
squared.
2x,
Deriving
2x,
x squared is
2x.
2x. Okay. The point is at -1, -2, 1 as given. So if you replace those numbers, what you get for ex, you get -2.
-1.
Okay, ey.
Oh yeah.
Deriving this with respect to y, how much?
6y.
6y. Y, 2 you replace, you get -2. Easy.
And then 4z.
4z, you plug in a z, which is a 1, you get a 4. So those numbers would represent your normal vector. The tangent plane has a normal vector, so which is delta e for the surface. Okay, and the numbers are respectively. Okay, that's it. You need a normal vector, you need a point, so the point is the given because it's at a point. That's it. And you put the formula, which is, if you want to put it, ex into x minus x the point. I'm writing the formula, okay? Plug in numbers and you get it, you can put it on the system. So it's a -2 here, 12, it's a 4. Okay, you have the pluses here, so this is all equals 0. So x minus you get x plus 1, minus you get +2, and finish. So that's what you can put on the system, okay?
Parametric form of the line to the point that is perpendicular to the tangent to the plane L1. So we'd find that line and then
Yeah, the parametric form of the line through this point that is perpendicular to the tangent plane. Situation is, this is a plane. Okay, the point is in the plane, we know that. Okay, you want to get to the line which pass perpendicular. I mean, this is the line that is passing through the point, right?
Yes.
I should pass it here. That's it. So this is the line they are talking about. They're very special because it's parallel to the normal vector. So for the equation of your line parametric, you need a vector parallel to it. So it's n. That's it. Okay. So in the second part, we have the line parallel to the normal vector. Okay. So this means v is n. The v is n. Okay. Again, this is the line because the line is parallel to the it's parallel to the n, and the vector direction should be parallel to the line. Okay, makes sense. What is v, by the way? What are the n?
That would be thought.
Right here.
Be -2. Oh yeah, that's -2,
-2, -12, and the 4.
4. Yeah. Constant ended up being 30, by the way. I don't know if that's necessary. Something.
Okay, and the point is -1, -2, and the 1.
Yeah.
Okay, now you want to write just the general form of the parametric. So the parametric equation of the line, the parametric line would be simply in general x equal y equal z equal. What are these? It's a. If you wanna put this like ABC, we prefer ABC.
-2t, -1.
The parameter t, b, t, c, t, and this represents the point, x the point, y the point, z the point. This is in general, right? So plug in numbers, and that's it. So the A, B, C's are -2, -12, and the 4. This is for the T. And the point, just to plug in. That's it. Presented in your system, okay?
How would I present it as a parametric equation?
Parametric, yeah, you
Like
put
a
a comma in
vector?
between these. So I guess you put commas right here. Is it?
I did, but I tried it with parentheses and then I tried it with the vector with the, but it's still saying it's wrong. So -2, -1, -12, -2, and then t plus 4. Yeah. No, it's doing it wrong.
So which one
That's
do you
what I
have
agreed
trouble
with.
in?
The second one.
The parametric line, yeah, see the way you present it, that's it. So what do you want to write? You write x equals
Minus-
something, comma, y equal this way. You want to present it or what?
I presented it as a vector, so instead of I just presented it like v.
Like v. It's a line. It's not a vector. For that reason, maybe check it the way you want to present it. Then
It sends me a message. Your answer isn't a parametric line. It
yeah.
looks like a formula that returns a list.
Okay, so it's that your web work just yeah, but they didn't represent it as parametric. This is vector form. The parametric in vector form. So they should specify it in vector.
They didn't specify it, yeah.
Yeah, and vector form would be written like x, y, z. And even they didn't write x, y, z. It should be what? The vector times t plus the point. So right here, yeah, as I said, you want to put it as -2, -12, if 4 with a t beside, plus the point, bracket, -1, -2, 1. So yeah, it's correct now. The way, perfect. Any question? Even this, they are not writing it in web work, okay? They're not
Sorry?
that part, only the way.
Yeah.
But in a test, what we are talking about in a test, it should be
But it would mean
or
the
the
same
way.
thing. Either way, whether I write it or not, that it's understandable.
By the way, when parametric equation of a line, this is the parametric equation of a line. This is the vector form of a line. So web work should indicate this, but for some reason they put that. Okay, in a test you should put this only. This is vector form. You have 3 forms to represent a line. You have parametric, vector, and you know symmetrical is x minus x, the point over a equal y minus, and so on. Okay. So yeah, you cannot like say put it parametric and you put this form. This is called ABC. This is called symmetrical, for example. It doesn't make sense.
Yeah.
But this is the way of the web work. Anyhow, web work. This is symmetrical.
Okay. Make sure that.
Okay, symmetrical representation of a line. This is parametric. This is a vector form.
Okay.
Okay, next.
4.
Okay, so what do you do? Yep. Number 4.
Number 4, we've got.
So this is a graph, a surface, let's say, okay, at which the vector is normal to the tangent. So this is given normal. Okay. So what they are talking about, you have a graph. Okay, I don't care of that graph. Let's say this is a surface of something, and that normal is a vector to the surface. This is n. It's normal to the tangent plane. Okay, tangent plane, and this is the surface given. the surface given here, you can call it, let's say, whatever, as f. So this is the function in x, y, z. You can collect. I prefer take z only. Either way it works. Okay, 3y squared minus z. Okay, perfect. So this is the surface f. So what do you want to find? Find the point on the graph where that happens. You want to find those points. Again, it's all about relation. What do you want to do? You want to combine all the skills, I mean, all the properties, right? So it pops in your mind anytime they say normal to a surface and you have a tangent plane, it pops your mind that your n vector is the same as delta f. That's it. Okay.
Yeah.
So what is your delta f right here? That's fine. Because the points are not, those would be in letters. Okay. So how much is fx?
Would be, so I just need 6x.
No.
Oh, sorry, x squared. I mixed them up. So minus 2x.
Minus 2x, fy.
And then 6y.
Fz.
And then this was minus 1.
Minus, finish. Now, the norm, this is equal to the normal, and the normal is respectively the numbers below. So what do you do now? You equate those to be the same, identical, right? Those are equal.
Yeah.
So those are equal. Minus 2x equal minus 8. So I got only 1 point, by the way. X equals 4. Yeah, 6y is, so y becomes minus 2. And now minus 1 equal minus 1. That, I mean, assures that those are equal. That's it. So if those are not equal, doesn't make sense. There's something wrong, either on your side, on the question side. You get it?
Yeah.
Makes sense? Huh?
Yeah.
Okay. Yeah, by the way, if by mistake you collected the function or the surface, the way you collect it, you take all those to the other side. So what do you get? You get z minus, let me write. You assign, if you assign f to b, because some students will say, okay, I want to take all those to the other side. So x squared. So when you right here, you get a 1, and right here it is a minus 1. You get it? So it won't work. It won't work. Right. Now that has a meaning, by the way. If that happens, so right here, what is your delta f? In this case, it would be minus 2x, comma, minus 6y, a 1. Now you want to equate it to the, if that happens, I mean, minus 8, minus 12, minus 1. Now it doesn't, because those should be identical. Do you agree?
Yeah.
What do you do in this case? I mean, in what happens, you won't go back and assign it differently. It's okay, but you do something to modify it.
Okay.
So should modify either of these in order to the equality to be true, because n equals delta f is true. Whatever way you assign delta f, whatever way you assign f, it should work. Now that doesn't make sense. That one is minus 1. So what do you do? What you do is you can take the minus of this or the minus of that, and that's it. Why that happens? Because if n is parallel to delta f, any multiple of n is still parallel to delta f. I mean, still minus n is parallel to f, delta f. Is it? Because they are proportional. Still proportional happens. Not only
would be in opposite direction.
I mean, minus, it's not equal, minus n parallel. I mean, parallel, not equal. Still the proportion happens. Okay. Yeah. Because if those parallel, okay, one of the vectors would make it equal. I mean, another way, n equal to delta f, so those are the same, right? If you want to change n, it would be a little bit apart from, it would be parallel. So the proportion still happen. Okay, so kn vector is parallel to delta f still. I don't care, minus, you can change it. Even if that is a half and you don't see it, so you can divide by even. They may play with this fact. Okay, so in my case, then you can multiply this by minus, so it becomes 8 and the 12 and the 1. Now those, then you can assign the rest and you get the same answer. Okay, perfect.
Yeah.
Anyhow, we prefer usually delta F mistake is to collect all towards Z. We collect all towards Z. Or the reverse, I'm saying. No, we collect, you take the Z to the other side. This is what we prefer. Instead of collecting all, changing all, we don't change all. We take Z to the other side. And that's what I did in the, I guess, right?
Makes sense.
In the beginning, yeah. So I took the Z. You see, the Z was here. So I took it instead of changing the rest. Anyhow, this is done, but I'm just pointing in case you face a difficulty in the relation. So what is the point? Is it done? Still the Z, by the way, we didn't Z.
Yeah.
So we have X, we have Y. How much is Z? You go back, you replace it to get Z. Okay. So where's the point? The point is on the graph. Still the Z. Get it?
Yeah.
X equal 4, Y equal -2. Okay. I'm putting back the equation to see it. Still Z, because you need the point. Okay, you say that the point belongs, so you have the right to plug it in. Okay, you get the Z. So the Z is 3y squared minus. You plug in the numbers you got. Okay. You get Z to be -4. So the point would be X and the Y and the Z. Any question?
No.
Good?
Yeah.
Okay.
Wait, could you go back so I could try it?
Which one?
Just try the answer just to make sure I don't forget
Yeah,
it. Or I could try it later. It makes sense anyways.
Yeah.
Perfect. Thank you.
Okay, number 5.
Like clears it up.
Okay.
Similar, find the equation of a tangent plane given point F.
Again, you will find the equation of the tangent plane to the graph. So this is given graph. Now it's a function R and S. You have the point has an X and the Y and the Z.
Z, yeah.
Yeah, you don't care.
Assign S. We could assign X as R and then Y as S. And
Yep.
Z is F of R and S. The same thing still. They're just trying to change it. Still the same.
So you need to find the normal vector, which is the F in this case. So it is F. Now we have F what? FR. Okay. And we have Fs. You want to derive this with respect to R, with respect to S, right? Okay. And now, if you collect this all on one side, it's already collected. Okay. Yeah. So what do you do? FR.
Derive. So FR would be -9.
Okay. So you see here, the function is defined in R and S. So there's nothing like X and the YZ. So you want to translate this meaning to the appropriate letters. That's it. So you see, no XY here. I mean, RS is equivalent, should be equivalent to XY. In this case, like an X. S acts like a Y. Any question? You get it? You wanna translate those names even. So the -114 has an R and S and a Z. You get it?
Yeah.
So this is your Z. Okay. Now Z for the surface and Z for the equation of the plane. Anyhow. Perfect. We don't have XYZ in the. So when you reach equation of the plane, we want to use RS. Anyhow, we would reach it. So for that reason, you have here like 3 coordinates, FR, FS, and you have FZ. Is it clear? Good?
Yeah.
Okay. Now let us collect, let us take this to the other side. it would be the same thing with the minus z. Okay, I will push this a little here. Okay, go ahead. So this is the same thing as before, but use different letters instead of x and y. So this would be, the surface would be 1 over that 3r cube. The way it is written, anyhow, to facilitate the derivative, that's it. Okay, so I want to put s this way. They put it separate just to facilitate the derivative form. Okay, minus z equals, let's say, equals to 0. Okay, but this is your surface that you are deriving. So derivative with respect to r is how much?
Is 3 minus 9.
Yeah, minus 9r square, and beside you have that guy acts like a constant in this case.
Yeah.
Okay, finish, come on. With s, I have 2 forms in s. Now those are not nice looking, so let us rewrite it in a power of minus because we want to derive it, so don't worry.
0 that way.
So let's rewrite
2
in terms of a minus, because if we want to derive, it's hard to act. We won't derive it like a quotient rule. It doesn't make sense. Okay. On a level, you can work with the negative exponents. Deriving with respect to s, you get this part, that part. Okay. So you have minus 2s minus 3. Continue. Minus goes to the front. 3 times 0.5 is 1 plus. R cubed, like a constant under times. S power. You subtract a 1 for minus 0.5. What do you get? Minus 1.5. Okay. Derivative for the z is a minus 1. Now, do we have a point? Yes. And the point now, be careful. If you treat this as like x, y, z, you are lost. So here we said, how much is r? So use the point. Let me write it here. Use the given point. What do I plug in? Yeah, tell me. So the given point has minus 1, 1, 4. And we said this is RSZ. How did I get it? I get it from here. The way they assigned. Is it okay?
Yeah, perfect.
Yeah, so that may happen in a test. They change letter names. It may not be RS even. Okay, they may choose ABCs, whatever. Okay, that's it. Let's plug these numbers. Get your delta F in as value. Okay, as a normal vector in value, because you need to get your equation of the tangent plane next. Go ahead. So this is my delta F. Okay. Yeah, plug in. What do you get for delta F? R is a minus. You get
minus 9.
S is a 1.
Minus 9.
Okay. Next, you have S is a 1, so minus 2. It won't affect the. Anyhow, you can use calculator. It's not a big deal. S is a 1, R is a minus. Minus with a cube is a minus, so it pops minus 1.5. I don't have Z in the rest. Is it okay?
Yeah, it makes perfect sense.
Yeah, we compute more, so you get minus 9 minus 3.5 minus 1. Okay, you are done with delta F, and you have the point at the point, which is minus 1, 1, 4. Now be careful again, we're not using X, Y, Z, we're using RS. So what is your formula? It is FR, R minus, okay, R the point. Okay, I'm writing the general form, but you can avoid it if you want, okay, if you feel it is hard. So instead of X, Fy now Fs, S minus S the point, you get it? Okay, plus Fz, Z is here still letter name Z, Z minus Z the point. This is the equation of the plane now. And it's a tangent plane. Is it okay? Now, if you avoid this formula, I mean, you can. You know that the delta F would be the numbers, beside the factors. I mean, just simply you can say minus 9, minus 3.5, another thing, and you have a minus 1 here. Okay, that's it. But this is the whole point. There's no x here. If you put x, you are lost. Okay, there's no x in the equation. It's r minus this point, so it's plus 1. It's s minus that value, and it's a z minus 4. That's it. Now this is in the test. You can stop or you can continue. It's up to you. What work you should isolate z. Go ahead. Isolate.
Yeah.
If you want to
Maybe
isolate
the
minus, so let us kick all this to the right side.
oh, this is the right side. Yeah.
This is
So
z minus 4.
9r.
I would add the 4 right away. So all you have to do, just write all this, add 4 to it. And that's it. If you want to non simplify. It should work.
It's simple.
Okay, so you got it correct. We'll do number 6. This has to do with the new lesson now. So compute.
We just did this. This is what we did this morning. The curl and the.
Okay, good. Yeah. So let me explain a little about this part, and then we do. So you have many questions here. We'll do part A first. Okay, and we'll go over the process. Now this can be done in 2 ways. We'll follow one of the ways and figure out. Okay, so what do you do right here, and what is given the surface, right? Now this is a vector field now. Okay, now we are working in a forms that has to do with a ij. Ij means this is a vector field. Okay, vector fields, it's written here. Now this is what the courses are about, by the way. They started by RT. Okay, you are doing the engineering course, which is multivariable in universities level. Okay, now the course starts by RT notation. It's like what? These are motion. Okay, it's a collection of points based on time. For t equals something, you are getting a point, another point. So this is the motion, or let's say the collection of points over time. It's RT, the motion. And then you get to surfaces, and then you get surfaces like fxy equals blah, 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 or fxyz, and then you get to the vector field. Vector field is a representation of a figure, okay, in a vector form. That's it. You are just taking different given, but the same application happens. You are still with delta f. You are still with the normal, tangent plane, and all this stuff. So what's going on here? Now decide whether it is conservative. If you want to apply,
I don't know what it is.
The curve should be 0 to be conservative by computing the or not. This you want to decide this yes or no by computing the curl.
Okay.
So how do you find the curl? Now this is beside P, beside J we call it Q. You can assign different names, but this is what they follow in the book. And beside the K in case you call it R, PQR. But here 0K, right?
Yeah.
This is R. Yeah, we need the curl to be in PQR. So yeah, how do you find the curl? Now you have
to do the
IJK PQR right here. And this is what you do. You want to derive this with respect to P. You derive this with respect to Q. You derive this with respect to R. Okay? It's a process. We do it as a process. So we have IJK. Yeah. So just those are, this is that you want to follow. PQR. Okay, so how much is P? 14x plus 6y. You derive back to x, y, z. Okay. Right?
Yeah.
Derive this with respect to x, y, and z. Yeah. I'm copying P. I am copying Q.
Or there's nothing.
So yeah, it's a process. Because we don't memorize curl as a formula, we make it on as a process. So
yeah, it's easier.
You just hide those, you derive this with respect to y, derive that with respect to z. So it's a 0. You get it?
Yeah, 0, yeah.
That's it. So this is the way we compute curl. Now you reach, this is minus plus, as you know. It's
Ends up being
permanent. So
0 again.
deriving that, so it means derive this with respect to x is a 0, derive this with respect to z is a 0. Okay, so we have big 0 again. That's what we expect, because to be conservative.
Yeah.
K, to reach the k, you do this. And
ends up being 6 minus 6. So 0 again.
Right.
This one is conservative.
Yeah, because when you hide those with respect to x, is a 6. Drive this with respect to y, is a 6 minus 6 to get a 0 back, which is nice. Okay.
Yeah.
So this is the way you want to show it to be conservative using the curve. So we got 0, which is 0i, 0j, 0k. Okay, perfect. Curl is a vector, by the way, it's not a value. A curl is a vector. So you can say it's either this format, an IJK, or vector form. Okay, so it means conservative. Vector field, the vector field is conservative. Okay, next question would be
not conservative and type of potential function f that is. So I just typed the
0,
now,
0, potential function, they denote it with a small f. So the potential function delta f equal big F. Okay, that's what you want to find. Delta f is a big F. Now the way you want to find the potential function, you want to integrate. Okay, so there's a process as well that we follow. Okay, I'm pasting again the question in front so we can see it. Okay, so how do we start? We say the function, potential function xy, would be integral of the p dx. You want to integrate this part first, okay, with respect to x, because component, y component, z component here is a 0, okay? So you integrate 14x plus 6y with respect to x first.
7x squared plus 6yx.
Yeah, 6yx plus a constant that pops, because when you integrate, the constant pops. Now the constant is what? The constant would be, in this case, a function in, what do you expect? A function, because you are integrating with respect to x, the constant in so we call it the g and y and z. So now let's call it now a function in y, gy only. Okay, now the second step is what? This is your potential function so far, but what is missing is to find the g of y. And we use now q. This is p, this is q. Now we don't derive. Now the derivative of the potential function with respect to y is my second component q. Okay, this is your second step. First step, always you integrate. Second step, you derive. And if there's a third step with the z, you derive again, okay? The derivative of the potential function is right here. I'm gonna derive this with respect to y. So this is that is a 6x. This is g prime in y. Is a q. This is the by theory. It's a q, 6x plus 8y. Now, how do you tell it? Fine, always at this step, because you want to find y, no x's would be present. Those should cancel. If at some point you get x, imagine that wasn't there, then there's something wrong on your side, okay? Always when you reach this step, you want to find y. So this is g prime y, be only in y. Then you integrate to get the gy function in y, which is the constant was in the previous step. So this is the 4y squared. And another constant would pop. Okay, now this constant should be a function in here. We don't have a z, it's a 0. That's it. So it would be only c. Okay?
Yeah.
I mean, this question so far doesn't touch the hard scenario. Okay, plus c. That's it. So all you have to put back your gy here and you get your potential function. So this is your potential function. So we say f of xy is simply 7x squared plus 6 yx or xy, okay, plus the function in y, which is the one we found for y squared. Okay,
Yeah.
that's it. Now you want to put the C or you don't. It doesn't make sense. Some now, some books or in web work they assign this. Yeah, you have it already. They don't put the constant. They don't put it, but in the test you put it. Okay. Now in on web work only have to do just put that part. Perfect.
Yeah.
Okay. Yeah, we'll stop right here. Then we continue.